Right, we're good. So welcome back, guys. This is week 3 of Intro to Backend. I hope y'all had a good weekend. And the demo 2 recording is up now. There was an audio issue from Wednesday. The audio from the Zoom recording didn't upload, so I re-recorded it over the weekend, and so that's up on the YouTube channel now. And it should be really helpful for PA2. So. All right, yeah, so some announcements. PA2 is due this Wednesday, October 25th. Office hours will be posted soon on Ed or the syllabus. I think they should be posted either tomorrow or Wednesday. And then grades will be released soon for PA1. If you have an issue with your grading, the person who graded you, they give you back a feedback form and it has their name and net ID. So yeah, if you have an issue with your grading, you can just contact them through there. So yeah, now we're gonna do a quick review of what we've learned over the past 2 weeks. So we have the client server model. The client is whatever device the user is using. So whether it be your phone, tablet, or computer that you're using to interact with the server. And so the client sends a request to the server. And so a route is triggered. And then some sort of data operation is performed. This data operation for our purposes is a CRUD operation, so create, retrieve, update, delete. And so during this data operation, the server is going to send an SQL command to our database. So we learned the different SQL keywords like creating a table or like retrieving or selecting data from a table. And the database will return some data back to the server. And the server will then return a response back to the client. So for, I guess, a high-level overview, we have the client sends a request to the server sends a command to the database, retrieves data from the database, and then the server returns a response to the client. And yeah. So now we're going to go over a single table database. So tables structure information into rows and columns. The columns represent a field with a defined type. So whether it be the ID or favorite flavor or favorite food, whatever kind of field that we want to know from our entries. And then the rows represent a collection of column values. So it could be an entry for me, entry for Caduce, entry for Matt, whatever it may be. And we query and manipulate data with SQL. So again, we learned the keywords, select, insert, update, and delete. And so we can query and manipulate data in the database using SQL. So yeah, so we've learned about routes, we've learned about databases, and the next thing we're going to do is learn about relational databases. So does anyone have any questions so far? All right, we're good. So for an overview, relational databases allow relationships between data. So touching on PA1, we had several comments for one post, but how do we actually know which comments belong to which posts? And also with like friends, if you have like an Instagram app or some other app where you can friend users, some users can have many friends, and those friends can also have other friends. So how do we know which 2 users are actually friends? And then also another example that this is useful for is relating transactions to who has sent a transaction and who has received a transaction. And so this is what relational databases will allow us to do pretty easily. So here we have a users table and we have a post table. So the users table, it has an ID and a name, columns, and the entries are Caduce and Tony. And the posts over here are barbecue is good and I love TikTok. And this third column over here is the user ID column. And so this user ID column sort of references the ID column in the user table. So you see that my ID is 2 and the user ID is 2. So that means this post is associated with mine. And so we do this in, I guess, backend using foreign keys. So the column in one table, so the foreign keys are a column in one table that uniquely identify a specific row. And they're also called like a secondary key. So again, this user ID field in our post table is referencing the ID field in the users table. And so, yeah, the foreign key column allows relationships between different databases, or different tables. So in our case, we had a relationship between the user table and a post table. So yeah, there's 3 different types of relationships. We have one-to-one, one-to-many, and many-to-many. A good way to think of this is like, I guess, mathematical functions in high school. Like a one-to-one function means one input, one output. A one-to-many can kind of, you can think of it as like you have one thing can reference many things. And then a many-to-many relationship can mean that one thing references many things, and the thing that it is referencing can also reference many of the original things. It'll be a lot more clear in a second. So the one-to-one relationship, so we have 2 tables, let's say, and row X in table A can only refer to one row Y in table B. And row Y in table B only refers to one row X in table A. So for example, we could have 2 tables of students and net IDs. We know that each student has a unique net ID. So each student has only one net ID. So the student references one net ID, and each net ID belongs to one student. So no 2 students have the same net ID. And so this is going to be a one-to-one relationship. So yeah, so here we have the user table and we have the net ID table. We see that we have 2 entries for the users, Shungo and Jessica. And then we have 2 net ID entries over here. And like in the previous example, this user ID column in the net ID table references the ID column in the user table. So from this, we can see that Shungo's net ID is SN685 and Jessica's net ID is JZS27. And so we see that a name references only one net ID, and a net ID only references one name. And so this is the syntax to kind of create a foreign key. So in our user table, it's going to be just the standard SQL syntax that we've learned previously. We have create table user. We have our ID, which is our primary key. It's an integer, and we auto increment it so that whenever we insert another user, it gets a unique ID that's one above the last user in the table. And we have a name of the user. We have text not null. We don't want a user to have no name because it's not practical. And then now the new syntax is going to be in this net ID table. So we're creating this net ID table. It's going to have, again, an ID, which is going to be the primary key, and we auto increment it. We have the actual net ID, which is going to be text not null. And we're going to have this column called user ID. So it's going to be an integer and it's going to be unique. And the reason why we have the unique keyword over here is that we only want one user ID to reference one ID in the user table. So this will prevent, I guess, 2 net IDs from referencing the same user. And then what we would do is we would put foreign key user ID. This indicates that our user ID is a foreign key, and this references the ID table of the user table. So this is going to be just inserting like a user into the table. So let's assume that both tables are empty. And so we insert one user with the name of Jessica. And then we insert into the net ID table our net ID, user ID, and the values are JZS27 and 1. And since inserting Jessica into the user table was the first entry, we know that her ID is going to be a value of 1. And so we're going to know that this net ID, JZS27, with a user ID of 1, it's going to reference the name Jessica in the users table. So the next kind of relationship is one-to-many. So we have row X in table A refers to many rows, Y1, Y2 in table B, and row Y in table B refers to only one row X in table A. So a good example is baseball teams and players. So as you know, each team can have many players, but each player belongs to one team. So imagine you have this team object. If you look at left green square, that could represent a team. And then the right green squares over there can represent different players. And we see that each player belongs to only one team, and the team has many players. And so we can also do this with songs and albums. So we see that we have two recent albums, Utopia and For All the Dogs. And we have these songs over here. So again, oh, my bad, team ID. That's supposed to be an album ID, my bad. So the album ID of 10 and 10 is going to be referencing the Utopia ID in the album table. And those are the songs in the album. And then also the last two entries in the song table of album ID 20 are going to be referencing For All the Dogs in the album table. And so, yeah. So this is the syntax for, I guess, creating a one-to-many relationship. So our album table is going to be the same as before. We have our ID and we have the name of the album. And then our song table, we're going to have the ID of the song, the name of the song. And then again, we're going to have this album ID be an integer. And in this case, we don't have the unique keyword because we want multiple songs to have the same album ID. So we're going to have integer not null. And then again, we're going to have the foreign key keyword, album ID, references, the ID column, and the album table. Does that make sense to everyone? Right. So for inserting stuff into the system, we have insert into table song. We have the name and the album ID, and we're inserting that Utopia is a new album with album ID 10. And if we do select all from song where album ID is 10, we're going to get Utopia as a return response. So the last relationship is a many-to-many relationship. And this is where row X in table A refers to many rows Y1, Y2 in table B. And row Y in table B refers to many rows X1, X2 in table A. So a good example of this is students and courses. So each student can be in many courses and each course can have many students. So like I'm enrolled in 4 courses right now, and each of these 4 courses has hundreds of other students. So yeah, so implementing this is a little trickier than the first two. There's 3 potential choices that you can do, and the first 2 are not as ideal. So the first way of implementing it is to have multiple columns to store more foreign keys. The second way is to have a single column to store a list of IDs. And then the third way, which is the best way, is a join or association table. So the first thing is we have this student table, right? And so each of these course columns right here is going to be a foreign key. This is the first way of implementing it. So if every student was in 3 courses, then this would technically work. It'd be an okay way of doing it. But what happens if a student wants more than 3 courses? So let's say this person over here wants to take 5 courses and is a tryhard. So then one option is to have all of these fields null over here, but that's kind of like a waste of space a little bit. And you also have to create 2 more foreign keys for course 4 and course 5. And it's just a lot of hassle. And likewise, if we have someone taking it easy, maybe he wants a chill semester, he's only taking 1 class, and all of these fields are null. This looks like a waste of space. I mean, it looks like 40% of the table is just not having useful values. And so, yeah, implementing it this way is just a large waste of space. And so the second way of having it is having a list of, I guess, items within the foreign key. So we have our ID, net ID, and courses table, or sorry, in our student table, we have the ID, net ID, and courses. And in the courses table, we have the ID, title, and students within these courses. So this with small amounts of data, this is somewhat practical, but yeah, so these are the relationships between the 2 tables. But if we wanted to add this new student who's in 1110 and 1998, then we have to have we have to add both course IDs into the courses column of the student table. And we also have to add this new student within the student column for every class that he's in. And so The problem with this is that it's not very efficient with regards to like time complexity. And the third option, which is having a join table, is a lot better to implement this. So yeah, so this is what the join or association table does. So we have a student table with an ID and net ID, and we have a course table with ID and title. And so what this association table does, it's basically two foreign keys, and one column is going to reference the student ID, and it's going to relate it to another foreign key, which is the course ID within this association table. So basically, we have a student with ID 1. We see that the courses that the student of ID 1 is in are in 1110 and 1998. And these correspond to the names CS 1110 and CS 1998. And we also see that we can find all the students that are in 1110 by just going through the course ID column and just kind of, you can visualize it as like, you could have an SQL query, say like select all from this table where our course ID is 1110, and we'll easily get all the students that are in 1110. And so if we wanted to have another student being added, so let's say Jessica, whose ID is 2, she wanted to enroll in 1998. You simply just add one row into the join/association table. So it's really fast to insert new data. And this is really fast for also large amounts of data. So this is the syntax to, I guess, create the two tables. This is pretty standard. This is kind of like what we learned in the last two demos. Our student table and our course table both have some primary key of an ID, and then they have the net ID and the title. And then so this join table is going to be our association table. So we have create table join. The ID is, again, like a primary key. It's not really going to be relevant for this example, but it's still good. You have to have a primary key. And so that's what the ID in this join table functions. We have a course ID whose integer is not null, and we have a student ID whose integer, or that is an integer that's not null. And so now we're going to have two foreign keys, where the first foreign key is going to be our course ID, and this is going to reference the ID field in the course table. And then our second foreign key is going to be the student ID, and this is going to reference the ID field in the student table. So did that make sense to everyone? I know I just went over a lot of material real quick. So does anyone have any questions right now? Yeah. So like after each student ID went on to like put in one column course ID, when the student goes to what courses I get into I think like joining. So you're saying what happens if you like try and join the two tables? Like when they like just don't use join table, just add to the original student table. That's the original student table. I think it's like when you're you're trying to say that you're adding a student to a new course. Is that how it is? Yeah. Okay. So the thing is that when you add the student to a new course, you have to find that course within the courses table. And then you also have to update like the course information within the courses table. And then you're also like updating some information within the student table. And so you're kind of doing two processes that aren't very efficient. Whereas with a join table, you simply just insert it at the bottom, and then it's a pretty easy query with SQL. I mean, I guess you could do that. But I guess it's good practice to just relate the two. So I mean, you could do that one way, yeah. I think it usually has to be at the end of the line, yeah.
All right, so now we're going to go into a demo of everything we just talked about. We're going to do that in SQLite. So just the SQLite terminal. This will be here. All right, one sec.
Hmm?
Sharing everything.
Okay, let's go for it. Yeah.
All right, so if you guys want to follow along, just open up your terminal, and if you've installed SQLite 3, you can do so.
Size.
Yeah, trying to figure out what it's going to.
Yeah.
All right, looks good to me.
Yeah.
So can you guys see that well, or did I make it a little bit bigger? Good. All right. So to start off, let's turn on SQLite. So SQLite. Oh, you can't see the top. Get rid of this. SQLite 3. And now we are in SQLite. Now you can just make tables and create databases. First thing you want to do is say pragma foreign keys equals on. And this, semicolon. And that activates foreign keys. For some reason, it's not activated by default. So to turn them on, we just do that. But that's not very as important. So first, we're going to demo how to make a one-to-one relationship. And we're going to do that with a users to profiles relationship. So we're going to say create table users. And you can say ID. This will be an integer. It'll be the primary key, as we've said. And we'll also want to auto increment it. And we'll say that users have a name. So name, this will be a text field, and we don't want it to be null. It's not null. And that's all we need for users. So we'll say that. And then we want to make a profile table, which will have some more info on users. So create table profiles. This will have the same ID type. So integer, primary key, auto increment. And you don't have to like capitalize anything. It's just kind of thing you get used to. It'll have, say, a net ID. So it'll have your net ID. This will be a text field and it'll be not null. And we want to connect the profiles in a one-to-one relationship with the user. So to do that, we want to have the key of the user as one of the fields of profiles. So we'll say user ID. And this will be another integer. And we want it to be unique so that we know that for every profile, there's only one user ID. And for every user, there's only one profile for them. So it'll be unique, and then not null. And then we have to say we have to create the foreign key. So foreign key, we say user ID. So this will be our foreign key. And we want to reference it to the users table on the ID field. And we close it. And that should work. If you guys want to see the tables you made, you just type in .tables. And you can see we have the profiles and the users tables. And let's start out by creating some users. So say insert into users, and we want to give them a name. So each user has a name and values. And one cool thing with SQLite or SQL in general is that you can do multiple inserts per line. So like I can say Caduce, then comma, and Tony. Let's capitalize his name. And semicolon. And that looks good. So let's test out that worked. Select all from users. And you can see Caduce has ID 1, Tony has ID 2, but you can't really see the actual columns. So if you want to see the columns, you just type in headers on. And then let's try that again. Now you can see ID name, but it looks like data. So let's also type in mode column. So let's select again. And now it looks a lot more cleaner. You can see that Caduce and Tony have been added, and you can see which data is the ID, which one is the name. But that's not as important. It's just a preference thing. So now that we have added those two people, we can now insert into profile. So go ahead and try doing insert into profiles. Profiles have a net ID and a user ID. And we want to add Caduce. No, not Caduce. We want to add my net ID, KMZ25. And I have user ID 1, so I'll put in 1. And then for Tony, we'll say AKM99, that's his net ID. And he has user ID 2 in the users table, so I'll put that there. And now we'll select all from profiles. And now you can see that my name, my net ID is in there, my user ID is connected to it. So some cool things about foreign keys, if you were, or unique keys, is that if you were to add into profiles, some net ID, like fake net ID, or I guess like AAA123, and then the same user ID as someone else. So 2, it will, oh, did I mess up? Yeah, I forgot something. Insert into profiles, net ID, user ID, values. You see that the unique constraint failed because user ID 2 already exists in profiles. Another thing that is interesting about foreign keys is that it doesn't let you break them. So if I were to delete from users where ID equals 1, it stops me because that user 1 has a foreign key relation to the profile KMZ25. So you can't delete foreign keys unless you delete the thing that depends on them. So I had to delete the profile first if I want to delete myself. So yeah, foreign keys just kind of constrain you from deleting things. And yeah, that's just a one-to-one relationship. You can say select, yeah. That's the one-to-one relationship. We have profiles to users. So now we're gonna try doing a one-to-many relationship. Well, wait, let's look. Does anyone have any questions about the one-to-one relationship? Or you guys are stuck on any part of it? Not, let's keep going to one-to-many. So we have our users, right? But we want one user to be able to like make multiple posts on some sort of like social media website. So we want to make a new table called posts. So create table posts. Each post has an ID. So this will be an integer, primary key, auto increment. Each post has a description. So like what the post is about, description, yeah, text not null. And each post has someone who's posted it, right? So it'll have a user ID to reference to. This will be an integer, but it's not going to be unique. We can also make it not null. So this allows us to have multiple posts relate to one user instead of it only being one-to-one. And we need to make the foreign key like before. So user ID points to references, users ID. And now if we do dot tables, we have a new table called posts, and we can start making posts. So let's make a post. Let's make 2 posts for me and Tony. Insert into posts, description, user ID, values. I should have thought about what I wanted to post. Please upvote my posts. I posted that one. And Tony would post, I lectured. Oh, you guys can't see this part. I'll move this away. I lectured today. So if I do select all from posts, you can see that I posted the first one and Tony posted the second one. And if I were to say post again, insert into posts description, user ID, values, I wish I lectured today. If I posted that, it doesn't stop me because it's not unique. So if I select all the posts, you see that user ID made 2 posts, but user ID 1 was able to make 2 posts. So that user has many posts. So this is a one-to-many relationship. And yeah, one cool thing you can do is say select users dot name posts dot description, and then from users, and then from posts where users.id equals posts.id or user ID. And you can see that now the name of the user is connected to the post, but you don't need to know how to do that. It was just kind of cool. And it shows that you can link together the two different tables. So Caduce posted to this one, Tony posted that one, and that was data from two different tables. So yeah. So that was a one-to-many relationship. Now we're gonna move into a many-to-many. So I'm gonna clear this. That actually worked. Oh, I probably shouldn't have done that. Yeah, we'll upload the videos if you wanted to follow along. But for clarity, we have right now posts, profiles, and users. We want to be able to say, make it so that each post can have a bunch of hashtags, but each hashtag can then technically have multiple posts. So having hashtags and posts is a many-to-many relationship, right? So if we wanted to make hashtags, we can make a table called hashtags. This is going to have an ID, this would be an integer, what is it called? Primary key, auto increment. And each hashtag has a tag. It could be whatever you want. Be text field, it's not null. And for this, we're going to show you that we don't actually need a foreign key in the hashtag. So that's just going to be our hashtag. So dot tables, we have hashtag and posts. So like Tony said, the way we're going to link the hashtag table and the post table is with an association table. So let's create that association table. Create table. And I usually like to call them like posts, hashtag, association, kind of like that. But you can name whatever you want. Each one can have an ID, integer, primary key, auto increment. And oh, I spelled increment wrong, but I can't go back. Let me do that again. ID, integer, primary key, auto increment. And so the association table is going to be the one that has the foreign keys, and it's going to point towards the hashtag table and the post table. So it'll have two of them. So let me make this real quick. So it'll have a post ID to be an integer. It will be not null, and it will not be unique either. We'll also have a hashtag ID, which will be another integer. It'll be also not null. And so we can make as many foreign keys as we want, as you saw in one of the bad examples. So here we'll make two of them. So foreign key, how do I do this again? Post ID, references, posts ID. And you can just put a comma at the end and make another one. Foreign key, hashtag ID, references, hashtags, ID. And then close it. Oh, I might have made a mistake somewhere. Oh, yeah, the worst thing about using the terminal is that I don't really know how to go back, so I have to do it all again. So create table, get the ID, post ID, hashtag ID, foreign key. I just missed a parenthesis, which is annoying. I missed it here. And now we made the association table. Go to tables. And now the association table combines the hashtag and the posts into this table. So you can link to both. So let's show you how to actually use it. So first we're gonna make some hashtags. So insert into hashtags. Each one has a tag, values, some good hashtags. General, course, says tag 3. I don't know. I think I made a mistake. Oh yeah, you have to make them each tuples like this. You gotta put them in parentheses. I have 3. And then select all from hashtags. Now we have some hashtags. We also have some posts from before. Select all from posts. And now we want to somehow create some fields in or entries in the association table to combine each post with a certain tag or a number of tags, right? So the way to do that is pretty simple. You just gotta say insert into what's it called again? Post underscore hashtag association. Each one has a post ID and hashtag ID values. I think post one gets the first hashtag. Post one also gets the second one. So maybe not the second one, maybe the third one. And I think the I lectured today post, which is post number 2, should get the courses tag. So that's number 2. And it should also get the general tag. So you can just add as many fields as you want. Select all from posts, hashtag, assoc. And you can see that post ID 1 is related to post or hashtag 1. It's also related to hashtag 3. And post 2 is related to hashtag 2. And is also related to hashtag 1. So if you want to actually see them together, you can say like select all from posts, hashtag, assoc. Not all, let's actually specify what we want to get. We want to get the post description. You want to get the hashtags. You want to get the tag name. We want to select it from the association table, the posts table, and the hashtags table. And you want to say that this only happens where do we do this? One thing you can do is that if your table is really long, you can say as and then give it like a shorter name. So I'll call it assoc. So now I can use assoc instead of post hashtag assoc, which is a longer word type. So I can say we're assoc dot posts ID equal posts dot ID and assoc dot what's it called? Hashtag ID equals hashtags dot ID. Hopefully this works. And now you can see that please upvote my post has these 2 tags. The other post I listed today has those 2 tags. So you're able to easily create a many-to-many relationship using an association table. So yeah, that's kind of all I've got. Does anyone have any questions about any of that? Not. Oh yeah. I don't know. It just does start at 1. It's just kind of how they do it. It's probably just a design choice.
What would you want to set up a join table versus just a long format database? Like if there's kind of like runtime generating.
So like having a one table that has just like this for every.
Example, going back to students who courses example, right? Like what if you just had like student like net ID name and then like the course, and the net ID name course. You just have one row for each course they're needing in that one database.
I think it's because like it'll be smaller than having one. So like if you had, say, a post and a hashtag, and one post had multiple hashtags, instead of saying post 1, hashtag 1, post 2, post 1, hashtag 2, post 1, hashtag 3, you can just have the post and the hashtag and then just have IDs for each of them. And also, I'm pretty sure it's more readable as it is now, but yeah, I think it's take databases like 44320 to really get all of that information. Even though I'm a TA for that class, I don't remember. So yeah, any other questions? If not, we can just go into the Kahoot. So, let's stop sharing.